Welcome to this Masterclass Explainer. Today, we're taking a huge leap, bridging the gap between theoretical engineering and modern digital construction. Think of this as your career-oriented roadmap. We're going to take you all the way from the absolute foundational concepts of building information modeling right through to the kind of industry-ready automated workflows you'll actually use out in the field. All right, let's just dive right into our syllabus for today. First up, we'll cover the overarching power and philosophy of BIM. Then we'll zoom into Autodesk Revit, explore some really cool computational logic with Dynamo, and finally wrap things up by looking at global open standards like IFC. Section 1. The power of BIM, going way beyond traditional drafting. Now, to truly understand today's architecture, engineering, and construction landscape, we've got to talk about the massive shift from traditional drafting to intelligent digital twins. The core difference here is honestly night and day. Traditional 3D CAD? Well, it's mostly just geometric expressions, basically dumb lines and shapes. But BIM? BIM is a living, holistic process. It actively injects intelligent, real-world behaviors and metadata into every single component. You're not just drawing, you're building a fully integrated database of an asset. And because of all that rich data, BIM becomes a true lifecycle management tool. It federates multidisciplinary data across literally every phase of a building's life. We're talking day one smart city planning, all the way through construction engineering and deep into long-term facility operations. And it definitely doesn't stop at 3D. Sure, we start with 3D modeling, but then we introduce 4D, which bakes in project schedules so you can visually track construction sequences over time. Then comes 5D, which brings in exact cost estimation and project finance. If you're an infrastructure professional or a project manager, mastering these dimensions is the secret to predictable outcomes, keeping things perfectly on schedule and on budget. Now, why does this matter to you? Mastering these processes opens up some incredibly sought-after career paths. Roles like BIM manager, BIM coordinator, and BIM technician are all about coordination, clash detection, and lifecycle management. Whether you're aiming for government jobs or private surveying roles, having these competencies makes you an absolute powerhouse in today's digital-first construction world. Moving right along to Section 2, inside Autodesk Revit, the authoring engine. Let's see how all this actually gets built by zooming into the specific software used to drive this digital methodology. Revit operates through highly specialized modules, so architects can be placing curtain walls, while structural engineers are simultaneously calculating reinforcement and load-bearing foundations using analytical modeling. Meanwhile, mechanical, electrical, and plumbing engineers are routing their systems in that exact same space. It's a completely unified engineering environment. But every professional project has to begin with a few crucial exact steps. You need to select the right templates, set your SI units and metric conversions, and establish foundational levels and grids. For all you geomatics and survey engineers out there, this is the critical moment. This is where your surveying mathematics, coordinate geometry, and elevation baselines get locked into the digital model, ensuring universal accuracy long before a single wall is ever drawn. Now, instead of drawing every single component from scratch, Revit uses parametric family creation. It's best to think of these like custom, loadable puzzle pieces driven by user-defined math. You design just one window family, and by tweaking the parameters you've set, it automatically scales and adapts to fit any size your project needs. So how do multiple civil engineers, architects, and detailers work on this massive model all at once? Revit uses a collaborative work-sharing system. It breaks tasks down into controlled work sets that all link back to a central file. This absolutely ensures data integrity and keeps large project teams coordinated without everyone stepping on each other's toes. All right, Section 3, Visual Programming with Dynamo, Automating the Ordinary. We're going to zoom in even closer now, right down to the computational logic that can automate those tedious manual tasks and seriously turbocharge your engineering workflows. This brings us to Dynamo. It's an open-source visual programming platform built right into Revit. Basically, it acts as a visual interface for a text-based language called DesignScript. It allows you to build really complex algorithms and explore computational geometry. And the best part? You don't need a computer science degree to use it. The anatomy of a visual program is surprisingly straightforward. First, you drop a node onto your workspace, which is essentially just a functional command. Next, you connect it with wires to pass data along to the next node. And finally, you hit execute. Boom. It instantly runs complex, rules-based designs. It's incredibly intuitive once you get the hang of it. And Dynamo manipulates data on a massive scale. We're talking about generating complex waffle grid surfaces from imported SAP files, managing massive n-dimensional lists, or even automatically color coding facade panels based on sun orientation. You are literally using pure math and logic to dynamically drive your engineering geometry. A perfect real-world application of this is Excel interoperability. Just imagine having to manually update the names and numbers of 1,000 rooms in a massive hospital project. Nightmare, right? With Dynamo, you extract all those REVIT room parameters into a spreadsheet, quickly edit them in Excel, and then use Dynamo to instantly push those updates back into the model. What used to be hours of manual data entry turns into seconds of automated work. Finally, Section 4, the Global IFC Standard, connecting the industry. Let's zoom all the way back out to the global ecosystem to see exactly how these intelligent models are shared around the world, completely regardless of the software you happen to be using. The reality is, no single software rules the entire global construction industry. That's exactly why we rely on standards. The Industry Foundation Classes, or IFC, gives us a vital, vendor-neutral standard for open BIM collaboration. As Building Smart defines it, it's a standardized, digital description of the built environment. And frankly, understanding global compliance standards like this is absolutely critical for any modern infrastructure professional. When you export your REVIT file to IFC, it preserves so much more than just the geometric shape of the building. The IFC data model explicitly codifies the identity of object types, the material and thermal characteristics, and the precise spatial relationships of every single object. It even captures abstract concepts like our 4D scheduling and 5D costing. What this creates is a totally seamless, standardized exchange workflow. An architect models a facility. The owner sends that exact digital model to a contractor for bidding, and ultimately, field survey technicians can provide a final, highly accurate as-built model. It essentially allows entirely different software systems to flawlessly speak the exact same language. And these specific vendor-neutral data encodings, like XML, JSON, and STEP, guarantee that your meticulously crafted digital twin can be transmitted, archived, and analyzed literally anywhere on Earth. This ensures long-term data integrity for smart city planners and facility managers, even decades down the line. As we wrap up this masterclass explainer, I really want you to consider how these tools are fundamentally reshaping civil engineering, construction, and surveying. The industry is evolving so rapidly right now, so ask yourself, as you build your career roadmap, will you be the one manually drawing lines, or will you be the one managing and programming the intelligent digital twins of tomorrow? Keep learning, keep pushing those boundaries, and I'll catch you in the next explainer.